Welcome to Everyday Mathematics. Our problem today comes from MIT 2024 Integration B regular season, and our problem of focus is problem number 1. Our problem is the definite integral from x equals to 1 to x equals to 2024 of the floor function of the logarithm to the base 43 of x. This is a very interesting problem. Before I jump into the solution, I'd like to thank our subscribers. Thank you so much for the support you're going to show us. Without your support, we wouldn't be where we are. For first-time visitors here at Everyday Mathematics, what we do is we go about and around and look for interesting problems such as this. We try and solve them. We come back with the solution that we think befit these problems, and we share them with you. For those of you who are here for the second or third time but haven't yet subscribed, we do encourage you to subscribe to our channel. Your support will go a long way in increasing the visibility that we do need to grow our channel. Now on to the solution to the problem. I think the first thing that we'd like to do is to define what a floor function of the logarithm to the base 43 of x means. That means that when the log to the base 43 of x is between an integer k and k plus 1, that means that the floor function of the log to the base 43 of x is equals to the value or to the integer k. As soon as log to the base 43 of x is equals to k plus 1, then this floor function shifts to k plus 1. Now, what does it mean for x? That means that in that interval, k is greater or equal to 43 to the power k, integer k, and less than 43 to the power k plus 1. So when we now try to plot this within the interval provided, that is between x equals to 1 to x equals to 2024, we'll have the x-axis and the y-axis shown here. So we have x horizontal, and then we have floor function of the log to the base 43 of x on the vertical. So when k is 0, obviously this is 1, and therefore log, that means that between k is 0 and k equals to 1, the floor function is going to be k, which is 0. And then when k now increases, now from k, between k equals to 1 to k and k equals, and k plus 1, and that means 2, means that this is x is between 43 to the power 1 and 43 to the power 2, which is 1049. And then the next interval, and in this interval, therefore, the floor function is 1. And then for the next interval, 43 to the power 2 and 43 to the power 3, the floor function shifts to 2, right? So we said between 43 to the power 1 and 43 to the power 2, the floor function is 1. And between 43 to the power 2 to 43 to the power 3, then the floor function is 2. However, our interval of integration does not go to 43 to the power 3. It only stops at 2024. So our integration is going to be limited to this blue dotted rectangle. So what does that mean? That the integral of the floor function of 43 to the log to the power log the base 43 of x from x equals to 1 to 2024 is going to be equal to this area here, which is 43 to the power 1, which is 43 times 0 because the height is 0. And then this area here, which is 43 to the power 2 minus 43 to the power 1, which is 43, times 1, which is the height. And then this area here, which is 2024 minus 43 to the power 2 times 2, which is our height here. So you can pull out 43 out, and so we have 43, and then in the bracket we are still left with 43 minus 1, which is 42. So we have 43 times 42 times 1. And here 43 to the power 2 is the same as say 1,849. So 2024 minus 1,849, obviously times 2. So this is 0, and here we have 1,806. And here we are left with 350, such that the final answer is 2,156. And this is the answer for this integral. Seemingly harder problem, but when you break it down to its core elements, it is easy to solve. So thank you so much for giving us your company. It was an absolute pleasure solving this problem. Until next time, adios.